Okay, in today's lesson you're going to be introduced to a new way of measuring angles, which is called a radian. So you know I've been telling you all throughout the year that this was coming and that at this point you only know how to measure angles in degrees. But today you're going to learn what a radian is and how to convert between degrees and radians for angle measures. Before we start that, I want to just introduce you to looking at angles as a revolution instead of just always looking at angles the way that we typically do. So this is an angle measure. It's a revolution around a coordinate plane. We look at a circle here, but we know all the way around is 360 degrees. So this revolution is only going halfway around, so we in degrees know that would be 180 degrees. Number 2 goes all the way around. One full revolution is 360 degrees. This is 3/4 of the way, so we know that's 3 of the 90 degrees, so that's 270, and this is 1/4 of a revolution, which would be 90 degrees. So that's going to be helpful to kind of look at angles as a revolution with some of the problems that we're going to be doing to that today. So before I introduce you to a radian, I want to kind of, I'm going to paraphrase, I'm not going to read to you, but I want to kind of introduce to you to why we use radians instead of degrees, because it is a way of measuring angles that you will see in higher math, more so than you will see degrees. So first of all, he has a clever way of introducing this, but he asks you, did you know that you speak Babylonian? And so we don't really think that we speak Babylonian because we don't know any words in that language. But you've probably noticed that in our number system, we count and we measure largely based on a base 10 system. So we have 10 years in a decade, 10 decades in a century, 10 dimes in a dollar. There's so many things that we carve up into tens. But if we look at time, we don't usually cut up our time into tens. We usually cut up time into multiples of 60, like 60 seconds in a minute, 60 minutes in an hour, and so on. So why do we do that? And that's because we base our timing system on Babylonian systems, which they were a base 60 number system, whereas we use mainly base 10. So that helps us kind of understand why we use degrees. It goes back to our Babylonian background for our number system. So we know what an angle is, and we know how to tell which angle is bigger, but we want to look at why do we have 360 degrees, and that's the base 60 system. But I want you to know that this is just an arbitrary number. They just chose this because they liked multiples of 60. But they could have just as easily divided a circle into 100 pieces or 400 or 10 or anything else. There's no mathematical reason why they picked 60 and making the circle 360 degrees. So as it turns out, there's a better, more mathematical way of measuring angles instead of using this arbitrary base 60 system. So if we have a full circle and we have drawn in a radius here, we want to talk about taking that radius and wrapping it around the outside of the circle. So you can see here, here's my radius that has been wrapped around the circle. Now how many times could I do that in the circle? Here's 1, 2, 3, 4, 5, 6 times of wrapping that radius around, but we're not quite to back where we began. So it looks like it's a little more than 6 times that we can wrap that length around the circle. So we're going to look at a formula that you should be familiar with, the circumference formula. Circumference is 2 times pi times the radius. So that tells us exactly how many times that radius length can go around the circle. It's 2 pi. It takes 2 pi of your radii to make up the circumference. So knowing this, we can now convert between radians and degrees, just as easily as you know how to convert between miles and kilometers and Fahrenheit and Celsius and so on. So I just want you to know the reason why we use radians is it's not based on an arbitrary base number system. It is based on the length of the radius. So I want to show you a little more clearly hopefully you can see this well enough, and I'm not sure if it'll let me use let me get situated here so you can see that. So we have a circle here, and you can tell this radius of this circle is 6. And I want you to see up here, we're going to keep up with the arc length and how many radians that degree is. Now, that's just a Greek symbol. I believe that's the lowercase theta for that angle measure. But that's just an angle measure is what it's saying. It's saying that angle measure in radians right now is 0.73. So I just want you to see, remember we talked about the radian is making the radius length wrap around the circle. So I want to make this radius length the same, the arc length the same as the radius length. So my radius is 6. I want my arc length to also be 6. So I want you to see what happens to our radian measure when I move point D so that the arc length, I really moved point D there, didn't I? I'm going to, excuse me, trying to get a little handle on this. It's not cooperating very well. Alright, so when I make that arc length exactly the same thing as my radius length, do you see the measure of the angle is 1 radian? That's all a radian is. It's the degree measure when the arc length and the radius are the same thing. So if I had a radius of 10, I would want an arc length of 10. And that angle would be 1 radian when that happens. So you may not have your head fully wrapped around that, but at least that's a good introduction to what a radian is and why we use them. So again, all a radian is when the arc length and the radius are exactly the same. The angle formed when that happens is a measure of 1 radian. Now we can find the radian measure by finding the arc length of a unit circle. And so remember, we've been introduced to the unit circle before. That's when we are centered at the origin and have a radius of 1. That's the unit circle. So we're just going to kind of look at what would the radian degree be for these that we know in degree measure. What would the angle measure in radians be? So we already talked about a full length around the circle. Remember, it would be 2 pi. It takes 2 pi of my radius to fill up the whole distance around the circle. So if 360 degrees is equal to 2 pi, 180 degrees would be half of that. It is pi radians, because it's just half of the full distance around. So 90 degrees would be half of this. So we know 90 degrees is pi over 2, or 1/2 pi. 45 degrees would be half of the 90. So if you take half of pi over 2, you get pi over 4. So those are a few of the conversions that you can find very easily just knowing the full distance around is 2 pi. So we've already got 4 of our conversions in degrees to radians. 360 degrees is equal to 2 pi. 180 degrees is equal to 1 pi radian. 90 degrees is pi over 2 radians. And 45 degrees is pi over 4 radians. So I have in your notes some of the most common conversions that you will see. When you get into Algebra 2 and Pre-Cal, you'll probably have a teacher that will require you to memorize the unit circle in radian measurements. So you'll know the degrees, but you'll have to write out the radians as a in terms of pi is how you'll write that conversion. I'm not going to make you memorize them yet. We're just introduced to radians in geometry. So when we're wanting to convert between degrees and radians, you need to know what is your conversion rate. Just like you know 12 inches equals 1 foot, or 60 minutes equals 1 hour. So we need to know what is our conversion that we're going to use for radians. So we already know, since 360 degrees is a full distance around a circle in degrees, and it is 2 pi of the radius, then it is 2 pi radians is what 360 degrees is. So 180 degrees, which is half of 360, would be half of the 2 pi, which is just 1 pi. This is what we use as our conversion rate. 180 degrees is equal to pi radians. This is just the unit. This is the number. Okay, just like the degree symbol is my unit and 180 is the number. So you're going to use dimensional analysis just like you're used to doing in science with your conversions. So remember, you're going to do your little T-chart and put in the top left what you start with. So you're either going to start with the radian amount or start with the degree amount. And then you put your conversion. Okay, remember to always put in the bottom what you're trying to get rid of. So if you're trying to get rid of radians, then you'll put radians in the denominator. If you're trying to get rid of degrees, you'll put the degrees down here. So you'll be putting 180 degrees and pi radians here. It's just which one goes on top. Okay, and then you just do your, the math. This is multiplication here and dividing by that number to get your end amount. So to convert from degrees to radians, you're going to have your degrees here. So I don't know how to spell, do I? So you're going to put your conversion here. So you would put the degrees down here and the pi radians here because you want your degrees to cancel out. If you're converting from radians into degrees, then you're starting with radians here. So when you do your conversion, you would put the pi radians in the bottom and the 180 degrees in the top, so your radians cancel. So just a couple of notes before we actually look at some examples. Typically, if you don't put a degree sign on your answer, then mathematicians or people that are looking at your answer will assume that your angle measure is given in radians. That's why I've been such a stickler all year long about make sure you put the degree symbol. If you give someone just an answer of 30 for an angle measure, they're going to think you mean 30 radians, which is really, really large. Okay, so when we are in degrees, we always want to put our degree symbol. Radians can be expressed using multiples of pi, which is typically what we do, but you can also write them as rounded decimals if you're given rounding instructions. Remember, you don't ever make up your own rounding rules, so if you're not given any, give your answer in exact terms, which is a term of pi. So what I mean by that is if you're given the full measurement around a circle, it's 2 pi radians. If you were told to round that to the nearest hundredth, then you would just put 2 times pi in your calculator and round that to the nearest hundredth. So you would get 6.28 radians. Now, what a lot of students will do when they're doing their revolutions is they'll translate their radian angles into degrees so they understand what's going on. But if you'll really try to force yourself to think in radians, you'll be better off because that's what you're going to be using most of the time in your higher math and higher science classes. Now, if you remember, when we were doing trigonometry, I told you it was really important your calculator mode. And it's because, remember, the default mode in your calculator is radians because that's what's used most in higher math. And we always had to change it to degrees when we were doing trig. It still only matters if you're doing trig. So you don't have to change your calculator mode to do the problems with conversion that you're doing today because you're not doing trigonometry. You will have to pay attention when you get into your higher math, whether you're putting your answer in degrees or radians. It'll matter what mode you're in if you're doing trig. Only when you're doing trig does it matter. Okay, so let's look at some examples. So our first example says to find the degree measure, and we're given the radian measure. So you're going to set up your T-chart for your dimensional analysis, and you're going to put what you're starting with in the first block. Since it's a fraction, you can put -3 pi over 4 in the numerator and the denominator. If you put it all up here, it's fine too. It's not a problem. Now remember, we're trying to get rid of the units, which right now are in radians. So I'm going to put in the denominator the radians. And my conversion again is 180 degrees is equal to 1 pi radian. So I'm going to put that pi radian down here, and I'm going to put the 180 degrees that it's equivalent to in the numerator. So really we're multiplying by 1 because those are equivalent to each other. Now notice what cancels out. Not only do the units of radians cancel, the pi's also cancel one another out. Pi divided by pi is 1, so that cancels. So to get our answer, remember if they're in the numerator together, it's multiplication. And then what's in the denominator, you divide by. So you're going to be multiplying the -3 by the 180, and then you're going to be dividing that number by the 4 that's in the denominator. So we get -135 degrees. Now, I hope you're thinking right now, how in the world do you have a negative angle measure? And we're going to get to that in just a moment, but it is possible. So that is a perfectly fine answer. If your answer is negative in radians, it's going to be negative in degrees. That negative sign does not go away. So let's look at our second example. We're given the degrees this time, and we want to convert it to radians. So when you set up your T-chart here, you're going to put 27 degrees, and we're going to use our conversion here, but this time we're trying to get rid of the degrees. So I'm going to put the 180 degrees in the denominator and my pi radians in the numerator. Only the units cancel this time, so the degrees cancel away. So in the numerator I have 27 times pi, and in the denominator I have 180. Now, I was not given rounding instructions, so when I do the multiplication and division here, I'm not going to enter pi in my calculator because we understand that that's irrational and requires rounding. So the only thing I'm putting in my calculator is this 27 divided by 180. And so when I do that and I get a decimal, since it terminates, it would be fine to give it as that, but we really want you to convert those to fractions every time you get a decimal. So hit math, enter, enter, and you would get 3/20. So you can write the answer one of two ways. You can put 3/20, but don't forget the pi is part of that answer, and then your units are radians. Or you can write that as 3 pi over 20 radians. Both of those are acceptable ways. Remember to not forget the pi. That's super important. 3/20 and 3/20 pi are not even close to the same number. So when you leave that pi off, it's completely wrong. So don't lose the pi. And then be in the habit of writing your units as radians, even though I told you if it's not there, it's assumed it's radians anyway. Now here is what I was talking about with positive and negative angles. When we have positive and negative angles, we're really talking about problems that are the revolutions like we practiced in the beginning of this video. And so it is important for you to know the natural progression around a coordinate plane is actually counterclockwise. Don't say left, because if you're in the third quadrant, you actually go to the right when you're going counterclockwise. So we say counterclockwise and clockwise, not left and right for that reason. But counterclockwise is the natural progression. And you should have learned that way back when you started learning the names of the quadrants in the coordinate system. We named them starting with the first quadrant where everything is positive, the x and the y are positive, and then notice we number them. You remember you made a giant C, but that's to the counterclockwise direction. That's the natural progression. And so when you go counterclockwise, you're always going to get a positive degree amount. So do you see the little arrow here? That is going to be a positive angle measure in degrees and radians. But when you go clockwise, that's when you get negative answers. So counterclockwise is positive, clockwise is negative. So really watch your signs on problems like this when you're giving your answer. Now, how do you know whether to give your answer in degrees or radians? If you're given part of your problem in degrees, then your answer needs to be in degrees. So this one tells me I want my answer in degrees. If the part of the problem is given to you in radians, then you want your answer in radians. So that'll give you a clue. This is a degree problem. This is a radians. So we're given from this part of the angle over to the negative side of the x-axis is 170 degrees. So that tells me this little sliver right here has to be 10 degrees because I know halfway around the coordinate system is 180. Now you're going to look at this little revolution to know what you're trying to give as an answer. So notice this revolution is going counterclockwise, so it's positive, and it goes around one full revolution, so that's 360 degrees every time I go a full revolution in degrees, plus that little sliver that we said was 10 degrees. So altogether, the answer would be 370 degrees for that revolution. Now let's look at the radians. And remember, I told you, I really don't want you converting this to degrees. Get your answer in degrees and then convert it back to radians. I want you to really try to think of this in radians. Now, first of all, since this revolution is going clockwise, I know my answer is going to be negative. So make sure your final answer is negative and that it has a pi in your units radians. So now all we have to really do is focus on finding the number part here. So we're given this part right here as pi over 3. So I want you to notice, how many times do we go the full revolution? So we go around one full time here, and then we go a full time again, and that gets us to this point right here. So remember, every full revolution is 2 pi radians. 2 pi radians is the same thing as 360 degrees. So we went 2 pi radians for the first revolution, and then 2 pi again. 2 pi, 2 pi. But then we kept revolving until we got to this point right here. And so we kept going pi over 3. So that's what I need to add to the other 2 pi's. So when you put this into your calculator, remember, don't put those pi's because then you're going to have to be forced to round. All you're going to do is put the coefficients and try to get that simplified. So you're going to put 2 plus 2 plus, that is 1/3. So make sure you put that fraction in parentheses when you enter that in your calculator. When you get a decimal, again, math, enter to get that as a fraction. So 2 pi plus 2 pi plus pi over 3 is 13/3 pi. So my answer is a negative 13/3 pi radians. Now some of your problems are going to involve a little more difficulty than what we just looked at. For example, you might have to find what this amount is in radians. So I want to remind you to look back at the sheet with the most common of your conversions right here. This will really help you. So understanding that every time you make a quarter of a revolution, that's going to be pi over 2 in radians. So I know that this whole distance right here as a revolution is a quarter of the whole coordinate plane, which is pi over 2. So if I wanted to know what this amount is, all I'd have to do is take this full amount of pi over 2 and subtract away that pi over 3. So in my calculator, I would put 1/2 minus 1/3. Remember to always put fractions in parentheses, and that would tell me what this little sliver is right here. Now that wasn't needed for this problem, but I just wanted to give you a heads up on some of the problems on your homework. Alright, so all you need to know at this point is just to understand that a radian is an angle measure, and it's the angle created when the arc length of that angle and the radius of the circle are the same number. And how to convert using your dimensional analysis between the two, and then how to give your answer for these revolutions. I'll be back at tutoring at 7:25 in the morning, but make sure you have these done so I can check them. You won't have time to do the whole thing in tutoring. All right, see you tomorrow.